Okay, and then friction is a force that opposes motion between two surfaces in contact. It's always parallel to the surface and opposite in direction. So if you're pushing your book across the desk, let me draw a picture of this.
Like this?
Yes, or a crate across ground. If this is your surface and you have your book or a crate or whatever it is, and you have an applied force in this direction, the force of friction is going to be the opposite direction. It's going to be parallel here. Now, next chapter, or the next chapter, I can't remember if it's this chapter, the next chapter, or 2 chapters, we're going to have inclined planes like this, and if you push, have an applied force this direction, our force of friction, again, is going to be parallel to this surface, so we'd have force of friction in that direction. So it's not always horizontal, it's always parallel to the surface. Max, you still have powdered sugar on your face.
Definitely didn't.
Looks like you've been snorting powdered sugar.
Only snorted one time. And Bart,
What?
the back, they have like clay, like glue, powder, like powdered clay. Just add water. You snort it and it gets shattered. It was like
Okay, so let's... Yes, those two are distracting. I'm sorry. So we have static friction, which is the force that opposes the start of motion. If you have something really heavy that you're pushing, you have to apply a lot of force before it actually starts to move, right? You can be applying a force to it and not have it move. So that's called the static force, or static friction, which is equal to the force that opposes the start of motion. Once the object is moving, then we have sliding or kinetic friction, which is friction between surfaces that are moving. And that sliding friction, once you get something to start moving, a lot of times you don't have to put as much force into it anymore, and you can keep it sliding at a constant speed. So to do friction, you have to have normal force, F sub n, and normal force is always perpendicular to the surface the mass is resting on. And it's numerically equal to the weight as long as we're on a horizontal surface. So if I have this surface again, and I have this object, and I have a weight force coming down, my normal force would be going straight up. And since they're opposite in direction, then they're equal in magnitude. Now when we get to inclined planes again, whoops, that's never a good inclined plane. Let me do a better job. Like this, and I have an object resting on the inclined plane. Weight is always just straight down. That's not very good either. I wish they had the undo button over here. I wonder if I can change that in my settings. There we go. So weight is down again, but normal force is perpendicular to the surface, so it's going to look like this, and when we get to this point, normal force does not equal weight. So only if it's on a horizontal surface does normal force equal the weight of the object. Force of friction we symbolize with F sub F, and F sub F is equal to mu times the normal force, and mu is the coefficient of friction. And a coefficient of friction depends on the two surfaces that are in contact. So if we have two rough surfaces in contact with each other, the coefficient will be a lot higher. If we have two smooth surfaces in contact, the coefficient will be smaller. There's also coefficient of kinetic friction and coefficient of static friction. So whether or not an object is moving or not is going to change the coefficient of friction. But for those two materials that are in contact, that coefficient of friction is constant. So if the same two surfaces are in contact and they're sliding, they're in motion, that coefficient will always be the same for that. for those two materials. Questions on friction? If we go to do some problems now, maybe? When we look and see whether or not an object with friction is going to be accelerating or not, because we could be moving an object, have friction, and be moving at a constant rate. We need to, in order for something to be accelerating, we have to have a net force of greater than 0. So if we look at net force is going to equal the force applied minus the force of friction, because they're in opposite directions. You have to subtract them. The net force is equal to the force up minus the force down, because they're in opposite directions. And tension minus the weight. Now, yeah, that's going to depend on whether you're moving up or down, I guess, really. Right here, out in front, right here. Sigma, it means net, the sum of all the forces. So the net force has to be positive in order for an object to be accelerated. Let's try a problem. A smooth wooden block is placed on a smooth wooden tabletop. You find that you must exert a force of 14 newtons to keep the 40 newton block moving at a constant velocity. Since we're going at a constant velocity, what is our acceleration? Constant velocity. What's our acceleration? 0. It's not changing speeds. It's not accelerating. It's not decelerating. Okay. What is the coefficient of friction for the block and table? So let's draw a little picture up here. From now on, a lot of times on your tests or quizzes, if you have, like where you have to give givens and unknowns, you can draw a diagram as long as it's a free body diagram labeled and everything. That'll work. What? Can I draw one and then you label it? No, you have to draw it. Because. So here is our weight. Weight is down, right? What is the weight of our block? $40 newtons. So what's our normal force? We're on a horizontal tabletop. So our normal force is equal in magnitude as our weight. So it is also 40 newtons. Now, since our acceleration is 0, do we have a net force? No, our net force is also equal to 0. That means that our applied force and our frictional force have to be equal to each other. They're equal and opposite, since there is no net force. So force applied is equal to, what's our applied force? 14, yep. So that means our force of friction is equal to 14. So if we want to find the coefficient of friction, what's our equation for friction? Mu times normal force. So if we're looking for mu, our coefficient of friction, we're going to take the force of friction, which is 14 newtons, and divide by our normal force, which is 40 newtons. and get our coefficient. What is it? 0.35? 0.35? Okay. Now, since we took a Newton divided by a Newton, does our coefficient have a unit? Nope, it's unitless. No units. So our answer for that would be 0.35. Now, this coefficient will always be the same as long as that same block and that same table are in contact and they're moving. So for the next question, it says if a 20 Newton brick is placed on the block, what force will be required to keep the block and brick moving at a constant velocity? So again, if we're going at a constant velocity, our acceleration is 0. So our force of friction is equal to our applied force. So if we can find the force of friction, that's equal to the force we have to apply to keep it going at a constant velocity. And, well, our normal force will change because we have more weight now. If we have a 20 Newton brick on here, what's our weight going to be now? Yep, let me change color here so I can... Ooh, you can't even see that, can you? So that means that our normal force is also 60 newtons. But we can still use the same coefficient. So now our force of friction is equal to 0.35 times our normal force is 60. Now, if it said that the brick was under the block and the block sat on top of the brick, we couldn't use that same coefficient. But since that block and the table are still in contact, we can use it. So what is the answer? 21? Okay, so that's 21 newtons. And that is the amount of friction. So if we want to move it at a constant velocity, we're going to want to apply 21 newtons of force also. Do we have any questions on that? Okay. Let's try another one. I think we have lots of problems that we can try. It doesn't. It has to do with net force. Suppose Joe, who weighs 625 newtons, stands on a bathroom scale calibrated in newtons. What force would the scale exert on Joe? If he's applying 625 newtons downward, what force would it... The scale is pushing 625 newtons upwards. He's not moving. If you're just standing still, you have to have a net force of 0, so there has to be an upward 625 newtons. So in what direction? It would be upward because weight is down. If Joe now holds a 50 Newton cat in his arms, what force would the exert on him? 675. If Joe puts down the cat and his father comes up behind him and lifts upward on his elbows at a 72 Newton force, what force does the scale now exert on Joe? 553. You just subtract 72. Okay. Does that make sense, those questions? The direction, so if he's... Yep. If he's standing right here and the weight is down, right? He's not moving downwards, so that means that the scale has to exert an upward force. Okay, the coefficient of friction between rubber tires and wet pavement is 0.5. The brakes are applied to a 750 kilogram car traveling 30 meters per second, and the car skids to a stop. What is the size and direction of the force of friction that the road exerts on the car? So basically, yeah, we're looking at force of friction. Are we moving at a constant velocity? Let's draw a picture here. Are we moving at a constant velocity? No. Because, so, I guess it's not asking for the applied force. It's just asking for the force of friction, huh? So our force of friction is equal to mu times the normal force. And our normal force is equal to the weight, because we're on a horizontal road. So what's the weight of our car? $7,350. And we know the coefficient mu is 0.5, so our force of friction then is equal to 0.5 times 350. So what's our force of friction? Half of that. $36.75. 36.75. Very good. Questions on that one?